Okay, so we talked the last couple days about locations of alternate interior, alternate exterior, corresponding inside interior angles. Yesterday, I showed you part of this where if you want to look at a grouping of alternate interior angles, hopefully this illustration kind of convinces you of the main property that we're going to deal with in regards to alternate interior angles. Okay? What would you say about alternate interior angles here if this is happening? They're going to be what to one another? They're congruent. Okay? Now that only works if the lines that we start off with, these two red lines, are parallel. Okay? If they're unparallel or non-parallel, those relationships do not exist. Click on this one, show the other set. Okay, I don't have them set up to where you can slide those, but if you can do it with these, then the idea is that they become those other ones, or the acute version, when you move that blue line, and then you can move them that way. Okay. Alternate exterior, is alternate exterior the same kind of principle? Okay, so alternate exterior angles are congruent. Here's your other version of those. Corresponding is the idea, so now it's just dragging that top one down to that one. Okay. Do they match up perfectly? Okay, so corresponding angles are going to be congruent. Here's the other set of those, third set of those, fourth set of those. And the last one is same side interior. Okay, same side interior starts off that way. We said they're supplementary. Those are the ones that are different. But the idea of reasoning why they're supplementary, and this is a way we can visualize this, because that angle right there should correspond to that one up there, that dark red one, right? And a solid red one. If those correspond, they should be congruent. And now if I look at both red ones up there, are both red ones up there forming a linear pair? Linear pairs are supplementary. But then when I bring that one back down here, it's the same angle, so the purple one and the blue one still have to be supplementary. Is that all right with everybody? Viewing that in regards to the supplementary angles? I think that's a huge kind of, I don't know what word I'm looking for here is, but it's a benefit, I think, to be able to see those things kind of in action, moving, develop those relationships. In the past, I've just had static pictures, and the pictures I don't think help everybody. Okay, that's kind of my goal here, is to make sure everybody understands what we're trying to convey here with these theorems. So yesterday we proved the fact that alternate interior angles are congruent when we start with the idea that lines are parallel. Okay, the lines that are cut by transversal are parallel. I want to do the same thing today with a couple other theorems. And as we do them, my hopes are the way that we go through the proofs, one is that it's pattern-oriented. So you see some similarities of what we've done in the last couple days. But at the same time, when we do our second proof today, my hopes are that you see the purpose of theorems and having theorems and the benefit of them. So that's kind of today's goal. Okay. First one I want to prove is corresponding angles theorem. And the way I want to prove this we're going to prove by knowing that the same side interior angles are supplementary. And that's the only thing I want to know. Okay, so we're going to approach this as if we have no idea about alternate interior angles, we have no idea about alternate exterior angles, and no idea about obviously corresponding angles, because that's what we're trying to prove here. Does that make sense? Okay. The only fact that I want us to use based off of parallel lines is that the same side interior angles are supplementary. Use that postulate that we talked about a couple days ago. Okay. Now, as we prove this, and we're going to write down the given in the proved statement by ourselves here, okay? So if I look at, let me just cut this out real quick. I want to go through different slides, this PowerPoint. We are trying to prove this theorem, okay? Remembering that if that's the theorem I'm trying to prove, the given is the if part, right? So we need two lines to be parallel. I'm going to choose two lines that I'm calling L and M. And that's going to help me then construct my picture. Here's line L, line M. We're going to have a transversal, so I'll put transversal in here. So as long as your picture looks roughly like that, you should be good to go. Okay? Now it says, then corresponding angles are congruent. So the then part is what we're trying to prove, right? Now our statement in our proof will not be the words corresponding angles are congruent, but we'll have to pick out in our picture a set of corresponding angles. And it doesn't matter which set you choose. Maybe I choose that one and that one. Would they be corresponding? Okay. Would those two be corresponding? What about these two? Okay. So all we have to do, guys, is identify one set of those corresponding angles. I'm going to use maybe 1 and 2. Okay, I'm just going to give them names so we can talk about it a little bit easier. If I didn't put names there, you couldn't talk about those two angles. All right? Our goal is to prove those, because they're corresponding. Our goal is to prove those congruent. Angle 1 congruent to angle 2. Okay? Now, there's a little bit of extra information here that we need to put into our picture that we're going to need. Okay? Throughout our proof, we're going to want to say that angle 1 and that angle right there, what would angle 1 and that angle right there be to one another based off of what we talked about yesterday as their possible? Careful, they're not a linear pair, but they have the same conclusion that linear pairs have. Those are supplementary angles, right? Well, how would I write? I can't say angle 1 plus that thing. Can't use like an arrow and say that thing right there. Okay, are supplementary. I'm going to have to give a name to that thing, right? So let's call that angle maybe 3 or whatever you want. You can call it angle 5, call it 12, whatever. Don't care. We'll call it 3. Taylor? By definition, linear pairs are two adjacent angles whose non-common sides form a straight angle. Supplementary definition is that there's just two angles that have 180, and they don't have to be adjacent. So those are the things that we're going to kind of develop on our own to give them the proof and the picture to kind of work through the proof of this theorem. And that's what is, obviously, I'm with you, and a lot of you are going to say this, is that proofs are difficult. They're hard. And they're hard when they provide us, or the author provides us, all the given, all the proof, and the picture. Okay? You can think about how much more difficult they become when all the author gives us is the phrase, prove the corresponding angles theorem. Okay? Because now we got to know what that means. Okay? We got to know that if two parallel lines are cut by transversal, the corresponding angles are congruent. Okay? We have to know the idea that the if part of that is my given, and I've got to be able to transfer that into specific things to discuss. And that the then part of that is the proof, and I got to convert that into specific things that I can discuss. And then that hidden angle 3 needs to be developed as well or highlighted so I can use it on my way to proving 1 congruent 2. So that's hard, right? And that's where I think a lot of times in a high school math class, they benefit you because they start you off with a lot of stuff. But it's like almost overnight that they start taking that stuff away. All right, so I want us to practice kind of developing that stuff on our own right now so that when they do disappear, we have to do everything. They just give me the film to prove that I have to do everything on my own, draw a picture, all that kind of stuff. We've had some exposure to that. Okay? So, the reason I want to prove this using just the same side interior angles postulate is because of some similarities that arise when we do that. All right. So we've talked about when we have vocabulary words that are given, we want to put down what those vocabulary words tell us. Well, parallel is the vocabulary word that are given right now. It doesn't tell me anything based off the definition, but after today, it should tell me 4 things. It should tell me that there's some angles that are congruent, 3 different sets of angles that are congruent, and 1 set of angles that are supplementary. Right now, we want to view this proof by going through and saying we only know that when I see parallel, we only know that same side interior angles are supplementary. Does that make sense, everybody? So that's what jumps off the page here. They say parallel, I know automatically same side interior angles are supplementary. So what are my same side interior angles here? Say it again? 1 and 3. Okay? 1 and 3 are my only angles that are identified as being same side interior. So I'll say measure of angle 1 plus measure of angle 3 equals 180. Okay? And that is the same side interior angles postulate, which said, shorten this phrase, but 2 parallel lines cut by a transversal, then same side interior are supplementary. Okay, that's kind of abbreviating that phrase a little bit. But that's what the same side interior angles postulate phrase for us a few days ago. Okay. Now, what we want to go through here, and this is similar to what we've seen in the class, we have got 2 options. Once we write down an equation like 1 plus 2 equals, or 1 plus 3 equals 180 there, we have 2 options. We can either replace 1 with something, replace 3 with something, or replace 180 with something. And the only way that I can do that is if I know throughout the previous statements or through the use of my picture that 1 is equal to something else, or 3 is equal to something else, or 180 is equal to something else. Does that make sense? If I look at my picture, let's look at our given first. Okay, the steps that are above this. Is there anything in that tells me 1 is the same as something else? Or that 3 is the same as something else? I don't have any equations here, right? Equality. So I can't replace 1 with something, or 3 with something, or 180 with something. I look at my picture, really the only thing that I could do based off looking at a picture is to see if 1 is maybe vertical to something else. Because then I have a congruency there, an equality I could replace, right? Does that make sense? And I don't have that. I don't have 1 being vertical to any of the identified angles up there. Okay? Somebody in the last class said, well, let's just say 1 is congruent. We know 1 and 2 are corresponding. Would you guys agree with that? And that's true, but what are we trying to prove? We're trying to prove the corresponding angles theorem. We don't know that that's true yet, so we can't use that in our proof. Does that make sense to everybody? It's the idea if I'm writing a definition, do I want to use a vocabulary word in my definition? No, because you never, say I didn't know that, say I'm trying to define supplementary, and I say, well, it's 2 angles that are supplementary. And I'm a person who knows what supplementary was. I looked that up, and am I ever going to know what that means? It gets me in a loop, right? Okay, I have a problem doing that. You never use what you're trying to prove inside your theorem, because remember, we're trying to prove it because we don't know it's true yet. The only thing that we write in our statements on the left-hand side are true facts. Okay, so I don't know 1 is congruent to 2 yet. I'm trying to prove that. Okay, so I can't use that. So substitution is not an option. That's what I'm trying to get at here. So substitution is not an option. What we've done in the last 3 days, and even before that, we try to write another statement that looks like that. What's that other statement? You get it? Absolutely. 2 plus 3 equals 180. Why is 2 plus 3 equals 180? Anyone? I thought the reason 2 and 3 are equal 180. If I look at 3 and 2, what do they create? Linear pair. There's your reason. The linear pair postulate. If we forget the linear pair postulate, put down what that says. It says linear pairs are supplementary, right? And we go straight into that argument. Okay, so hopefully some light bulbs are going off. Okay, we're hopefully seeing some things here. What do we know about those? That's terrible, but what do we know about those two things that I highlighted? They're what to one another? I gave you the number 180, and I think if somebody else with number 180, what do you say about those two numbers? They're equal, right? They're the same. Okay? So what that tells me, what can I write now next, Jenna? Good. Okay. So if the 180s are the same, the argument that we've made over and over again is that those two algebraic expressions of 1 plus 3 and 2 plus 3 are the same. Okay? And then the idea is, you think about it, this statement here is simply the left-hand side of statement number 2. And instead of writing the 180 that's on the right-hand side of statement number 2, I write that as the right-hand side because we said in statement number 3 that 180 is the same as 2 plus 3. So that's just substitution, right? Okay. If you're a person that says transitive property there, I'm not against that. Okay. Would you guys agree with this? Like if I wrote this way, 1 plus 3 equals 180, and then 180 equals 2 plus 3. I ran there. Would you go like this is an A idea, this is a B idea, this is a B idea, and this is C? Does that allow you to get from A to B and then B to C, go from straight from A to C? That's the transitive idea, right? If you want to do that, I don't have any issues with that. Okay. I think most of the time, most textbooks, Math Excel, that kind of thing, is probably going to use substitution. But you can argue transitive there. I don't have an issue with that. Now, in the past, when we get something like this, we have a sum on the left, a sum on the right. The goal or the hope is that there's an object on both sides that is able to be removed, right? What can you remove from both sides there? Angle 3. So that leaves me with 1 equal to 2, right? What do we do if we're removing something from both sides and it's the same amount from both sides? Good, subtraction. And now the last step here is kind of a procedural thing. I think it's important now. If I've got measure of angle 1 equals measure of angle 2, that's saying two numbers are equal. Okay, it doesn't say anything about congruency yet, but those two numbers represent angles. So we know that the value, or so the object those values come from are the same shape. And if they're the same value, that means they're the same size. So we've got same shape, same size. Same shape, same size leads us to congruency, right? And that's going to be, when we say same size, same shape, that's our definition of congruency. Okay? If you want to write, again, congruent angles have equal measures, or equal measures come from congruent angles, something like that, that's fine. But does that get us to what we wanted to prove? Now think about what we did. Okay? We started off with just generic L and M, two parallel lines. We've now proven that 1 was congruent to 2. Well, 1 and 2, they were corresponding angles, right? So we start with parallel lines. We've now concluded that corresponding angles are congruent. Okay, and we've proven that theorem that we set out to prove. Okay? But here's my argument. Go back one proof in your notes and compare that proof we did yesterday of alternate interior angles to this one of same side, or sorry, of this one of corresponding. Is it the exact same proof, the exact same 6 steps? Okay? Obviously, the numbers are probably different, with the 1s and 3s and 2s and 3s and that kind of stuff. But the procedure is the same. Same statements on the left, same exact corresponding arguments or reasons on the right. Okay? And that's what I want to kind of shed light on. That's what I'm trying. Hopefully, you think I'm beating a dead horse and that you understand this and you get this. Okay? Because that's proofs in general. All right? We might see over, I don't know, 100, 150 proofs this year. Okay? But they can all kind of be categorized in like 5 different styles, 5 or 6 different styles. Okay? This is a particular style. We see this procedure over and over and over again. Okay? So that's the corresponding angles theorem. I want to do one more. I want to do this one. If 2 parallel lines are intersected by transversal, then alternate exterior angles are congruent. If 2 parallel lines are intersected by transversal, then alternate exterior angles are congruent. And I just put that there just to remind myself that I don't want to use the first way we go about this. I do not want to use anything other than that proof, or sorry, than that property, that same side interior angles are supplementary. So even though we know now that corresponding angles are congruent, we know now from yesterday that alternate interior angles are congruent, I don't want to use those facts in this first proof. Okay? Because again, we're going to see patterns. We're going to see the idea that, Britain can do it one way, okay, and I could do it another way. His might be 4 steps, mine might be 8 steps. We both reach the same conclusion, and we both have solid arguments to back it up, okay? So we're going to do this 2 different ways, and hopefully that sheds light on some of the discrepancies that we could have with proofs, okay? But if our arguments are still valid and there's no gaps, we're both right. So again, just trying to walk through the if part. Remember, the if part is our given. So just starting off with parallel lines, right? So identify our given as that. Just say, we just use lines L and M again. L is parallel to M. And as we're doing this, I'm going to try to start drawing my picture over here on the side. Line L, line M. They're parallel. We want to prove then that alternate exterior angles are congruent. So it's the same kind of logic as the last one, guys. Would you guys agree that those are alternate exterior? You can put your angles there, or you can put your angles there. Doesn't matter which ones you use, okay? Because once I prove that set, I've proved alternate exterior angles are congruent, which means I've also at the same time proven that set to be congruent, okay? I'm going to use that set, and I don't care what numbers I use. Use 7 and 8. Identify those angles. Okay? Now I'm telling you that those are the angles that we want to try to prove. So angle 7 is congruent to angle 8 is our proved statement. But in my picture, guys, obviously, hopefully this makes sense to you. If that's all I had in my picture, you can't talk about anything else, right? There's nothing else up there I can discuss. I don't have any other relationships with 7 and 8. A lot of people will say, well, just say 7 is congruent to 8. But that's what we're trying to prove, so we can't use that. So I need to have other things in my picture, okay? If you weren't sure, I guess an option would be just to name all the other angles and start talking about all the relationships that maybe you know with other angles. But because I've defined for us that we're going to deal with same side interior angles or supplementary, that's the statement that I want to use to kind of drive this. I'm going to talk about a pair of same side interior angles. It doesn't matter which set you look at, and it doesn't matter what you call them. Call mine 1 and 2. You want to call yours A and B, or alpha and beta, whatever. It doesn't matter. Okay, just something so they have names so you can talk about it. Okay. If you're a person that likes to call that a point, I call that A. Come over here, call that a point. B, maybe call that C. You can name angle 2 as like BAC or something like that. Okay. You can use those two the same way. All right. So using these two same side interior angles would produce the same result as using those two. Doesn't matter. We just got to use one side. All right. So now we've got stuff. And like I said, generally speaking, 99% of the time, guys, they're going to give all that stuff to you. But I think it's important to understand where that's coming from, why they know what to give you. Okay. Draw L parallel to M. All right, now I want you guys, because I want you to use, when we see the word parallel, right now, the only thing that we should know from that, based on how I want you to prove it, is that same side interior angle is a supplementary, right? So write down a statement, the left-hand column there, that you know is true because those lines are parallel. And it's very similar to what we've been doing the last couple proofs. You guys agree with that? 1 plus 2 equals 180? Okay, well, measure of angle 1 plus measure of angle 2 equals 180. Same side interior angles, not a theorem, my fault, postulate. Again, I don't care if you know it's postulate or a theorem. I care that you know the fact is true. That is a postulate. Okay, so when we've seen that before, we have done other things. Okay, we have, generally speaking, the route we've gone the most is if I have that statement, don't I make another one very similar to it? You have another set of angles up there that you know for certain will write down or will create an equation very similar to that. You guys agree that 2 plus 8 equals 180? Because 2 plus 8, don't those two angles make that blue transversal? So they make a line? So what reasoning do I have for 2 plus 8 equal 180? Linear pair postulate? All right? All right. Take a minute. See if you, with those two statements in 3 and 4, reproduce the pattern that we've been going through. Okay? Come up with statement 5, and come up with statement 6, and see, and maybe you can even come up with a statement 7. This does go a little bit longer than six steps. See if you can kind of work through and see the link here. Jayla? Yes, I did. Not very good accountant. My job, but 3. You guys agree with that? 1 plus 2 is equal to 2 plus 8. Now, I should be saying measure in front of those, but short things. 1 plus 2 equals 2 plus 8. What property or what reasons you guys give on that one? Absolutely. Okay. And what is on both sides? 2. Let's get rid of it, right? Measure angle 1 equals measure of angle 8. Subtraction. Okay, so we've been doing this, and we got 1 equal to 8. Let's say 1 congruent to 8. And we've always said that's the definition of congruency, right? Those 6 steps are exactly what you did in the first proof of class. The same one we did yesterday. We've seen it before as well. But did that get me, and the hope is that when we get down to this congruency, that matches up to what I want to prove. How does that match up to what I wanted to prove? It didn't, right? That's okay. That happens sometimes. All right, and that's the thing that we've talked about in the past. Like, a lot of these questions, we haven't really addressed the proof statement or what I'm trying to get to until it just kind of falls in our lap at the end. Okay, I don't know where to go from here. 1 is not, or 1 is congruent to 8, but that's not what I want to prove. 1 and 8 are actually just corresponding angles, right? So we just kind of went through the corresponding angles theorem proof again, which is okay, because what happens when I look at my picture? Is there a link up here in my picture that's going to allow me to replace 1? Because if I look at that statement right there, 7 congruent to 8, and look at this statement here, 1 congruent to 8, the difference is that I want that 1 pulled out and replaced with 7, right? Does that make sense? Is there a link in my picture that allows that to happen? What do you know, those of you shaking your head, what do you know about 1 and 7? They're vertical angles, okay? So let's write that down. Angle 1 is congruent to angle 7. The vertical angles are congruent, right? So we'll write vertical angles theorem, that's fine. Now look at statements 6 and 7. 1 is the same as 8, but 1 is also the same as 7. So what can you say about 8 and 7? Yeah, they're congruent, okay? And the idea, the way I read it, guys, I would kind of maybe flip-flop the 1 and the 8. I would read it as angle 8 is congruent to angle 1, but angle 1 is congruent to angle 7. And you see that angle 1's in the middle, right? That middleman. So we can get rid of it and just leave the 8 and 7. What property is that? Good. Transit. If you said substitution, that's okay. Right? It's similar. The transit property of congruence.
If you were to put, for instance, either at the beginning, would that have something to do with that?
Okay, so good question. So this phrase right here, guys, 1 congruent to 7. Did anything that we did right here impact or make me, all the way up to statement 6, did any of that stuff help me create 1 congruent to 7? Or that when I looked at my picture at the beginning, I knew that 1 was congruent to 7 right at the beginning, right? So that statement can actually float around anywhere between and even before statement 1. You can go to 1, you can go there, you can go between 1 and 2, you can go between 2 and 3, 3 and 4, 4 and 5, 5 and 6. It just has to be stated before I make that argument 8. And that's the idea of, that's a good question, that's the idea of what we call independence. There's nothing, that statement is independent of anything else. It does not depend or require anything else to make it, okay? Now, 1 congruent to 8, 1 congruent to 8, that statement right there is dependent on steps 1, 2, 3, 4, and 5 coming before it in the order that they came before it, okay? So statement 6 is a dependent statement. So that's a good question. Now here, benefit of theorems. When we were doing this, we got down to 1 congruent to 8. I said 1 and 8 were corresponding angles, right? So essentially, we got to that point right there, and all we've done is prove the corresponding angles congruent. But if I have that theorem already kind of in my toolbox of theorems or properties to use, let's see how much quicker this proof is. You don't have to write this down. If I have L parallel to M, obviously that's given, right? Now, okay, just kind of using the idea that Shayla said, we automatically say 1 congruent to 7. Okay, if I want to put it there, step 2. Vertical angles are congruent, right? Now, these 6 steps right here got us to say that 1 was congruent to 8, right? Angle 1 is congruent to angle 8. And if we have already seen that somewhere else, like we have, we can say that that's the corresponding angles theorem. And that step right there kind of condenses or consolidates those 6 steps into just one. That's a nice thing, isn't it? Okay, saves a lot of writing, correct? Saves a lot of argument there. Okay, and now if I've got 1 to 7, or 1 also goes to 8, can I jump straight to 7, congruent to 8? And again, that's because of the transitive property. You see the benefit of theorems and why we have them? Okay, they allow our arguments to be more concise. Okay, instead of having something that's strung out like we have on the left-hand side, we can compact it to something a little bit shorter. Okay, people prefer those. Okay, if I'm going to publish this, I'm probably going to publish it the way we wrote it the same time with 4 steps. Okay, but the idea is, you know, initially we went through it this way because maybe that's just the line of thought that we had. When we're done, say it's a rough draft, right? When we're done, we say, okay, can I maybe say this a little bit better? Maybe say it, condense it. You've all had like run-on sentence and stuff like that inside assignments, writing assignment, right? Or you've had, maybe you're just writing in a paragraph and you've gone and just restated the same thing over and over again a couple times. So you take all that information out. That's kind of what we're doing here. Okay. So if I'm going to write this one or publish this one here, it's probably because I already had this written somewhere and I understand. Then I can condense a portion of it. The end of course exam guys ask you sometimes, not all the time, but sometimes, to look at a proof this way. Okay. This will be the last one we do, and then we'll get some. I can show you some algebra examples. But they ask you, they kind of set some predetermined steps, statements, and reasons for you, and you just got to organize them. Okay. This can be the issue, I guess, with this one is you have to now abide by that author's structure of the proof. Meaning that if we've been doing maybe 2 steps that this proof does, we've been doing them as 1 step, but it's broken down into 2 steps here. We might have to pay attention to that. So here we're asked if we're given 2 lines that are parallel, A and B are parallel. Can you prove angle 1 and angle 8 are supplementary? What kind of angles? Now we don't have a definition. A textbook does not define these, and no textbook ever will. What kind of angles would you call 1 and 8 based on the structure of how we've been talking about all our angles so far? Same side exterior angle. Okay, on the same side of transversal and they're outside of A and B, right? What we're trying to ask us to prove here is if angle 1 and angle 8, those same side exterior angles are supplementary. We're going to prove it. And that means that that's a fact all the time. Does that make sense? If you start off with parallel lines, then same side exterior angles are supplementary. Why doesn't our textbook use that? Okay? Why doesn't our textbook write that as a theorem? And the reason for that is it's just not as important as the other theorems. It doesn't get used as much. Think about this. If I'm a quarterback on the football team, I get to play 50% of the game, right? Okay. If there's 100 plays, I probably get to play in about 50 to 60 of them. If I'm a kicker on the football team, there might be 100 plays and I get kicked once or twice. Who's more valuable in that situation? Who has more clout? The quarterback or the kicker? Probably the quarterback, right? Does that make sense to everybody? Okay. He's used more often. He's a bigger component. Now, that's not saying kickers are unimportant because they are, but the idea is this proof, this theorem that we could come up with here is kind of like the kicker. All right? It's important, it's true, but we don't use it very often. Okay? So we don't usually write it as a theorem, but it is a fact that is always true after we prove it. So this is kind of what's going on here, is that they're going to ask us to click and drag these boxes. So do the first one here. You guys agree with that? Okay. Now look at my picture. What are some things in your picture that you know automatically to be true based off your picture? And hopefully then you maybe glance down at the statements below and validate your argument. Okay? Down? Okay, so what we've been doing is that 5 and 8, we look at that and we know they're automatically a linear pair, so we make the jump that they're supplementary, right? So down saying 5 plus 8 equals 180. And he's going to say that's because of the fact that linear pairs are supplementary, right? Here's the thing. If I do this, and you're absolutely right, that's the way we've been doing it. We're going to get through the proof here, and we're going to have some leftover stuff. Because the author of this proof has already provided us with some ideas that we have to use to exhaust all these options. So before we say that 5 plus 8 equals 180, let's say that first. Okay? Does that make sense? And that's because they are a linear pair, right? So let's see here. So I'm going to write that. I'm going to put them that way. Now what we've been doing is we've been taking those two steps and putting them together. We just look at our picture and we jump straight to 5 plus 8 equals 180, right? The logic of why we're able to do that is because of those two steps individually. We just encapsulate them kind of in their own, because they come all the time, they repeat themselves all the time, so they're writing those two steps every single time. We just make the jump straight to this, which is good, it's fun. But the author says that we've got to use all of his steps. Okay? What else could I say based off my picture? And now, remember, the only thing we can't say is that 1 and 8 are supplementary. Everything else, we know alternate interior angles, alternate exterior angles, alternate, corresponding angles, and same side interior angles. All those facts are true. Down? Yeah, angle 1, same side, right? 1 and 5. What kind of angles are 1 and 5? Corresponding. Okay? So we can use that. Right now, after today, we can use any of those 4 properties: corresponding, alternate interior, alternate exterior, same side interior. Any of the relations that exist with those, we can use them as we want, as we see fit. Okay. So 1 and 5 are congruent. Down. Okay, 1 plus so you took this statement here and replaced it. So you replaced 5 with 1, right? Okay, so I want to put this in first, because if I don't, going from that statement to that statement, using these two to get to this one where my cursor is kind of a false approach, because in that top one where it says measure of angle 5 plus measure of angle 8 equals 180, that's a number plus a number equals 180, right? Well, if I substitute angle 1 in for measure of angle 5, I've now replaced a shape with a number, or a number with a shape, and we can't do that. Does that make sense? So I want to convert this. It's a technical thing. I want to convert this set of congruent shapes to a set of values that are equal, and now make that substitution. So 1 and 5 are the same. So I replace that 5 with 1. That's substitution. And now if 1 and 8 add up to 180, aren't they supplementary? And that would be our definition of supplementary angle. Okay? I like you guys seeing that, because I think it's important to see when you are provided structure, whether Math Excel's got like 3 or 4 statements already written, or a couple reasons already written, you got to go fill in the blanks, or kind of click and drag like this. They are providing you a route they want you to take. They're trying to guide you in a particular way. And I think it's important that we can do that at the same time, maybe do it our own way if needed. There are just a couple things, guys, in regards to the assignment that's online. There's a couple algebra problems at the end. My suggestion, so you guys see stuff like this, and I think we talked a little bit about this yesterday. They're going to ask you, find all those measurements. Do not try to go right away and say, well, angle 1 is the first one I got to input in a Math Excel, so that's the first one I'm going to start with. Because you might not be able to make the jump right away from 105 to 1. Does that make sense? My suggestion to you is do something like this. Take a piece of paper, take your hand, cover up one of those lines that's not useful. That one's not useful right away because there's no information over there. 105 is the only piece of information they gave me, right? Can you now make the jump that 3 and 5 are both 105? And so is 7. Okay, so then, once you do that, you have the ability, if you knew that 7 was 105, do you now know 6 is 105? Do you now know that 4 is 75? Does that make sense? Then can you do this? Can you cover this part up? I know this is 105, 75, so 1's got to be 75. That's got to be 105, and that's got to be 75, right? So you might have to redraw, cover things up to kind of shed light on things. Let me do this one here with you, and we'll be done. You guys can leave in a moment. You see something like this. Anybody know what kind of shape that is? Trapezoid. Okay, trapezoid by definition is a quadrilateral, four-sided shape that has one set and only one set of parallel lines. I highlight that parallel line and highlight that parallel line. Okay, so the segments in the trapezoid are parallel, but the lines that they came from were also parallel, right? What would that line right there be for? Okay, that'd be the transversal. Can you see that this is 2x? And this is x minus 12. And then when I take that image out of there, is that the kind of the run-of-the-mill, traditional, general parallel lines and transversal image that we've been looking for? What would be the relationship between those two angles? Supplementary. So we take 2x plus x minus 12 equals 180. And you guys have been solving that since you're like 7th grade. Okay? Now, when you do these types of pictures and mess around with them, just depending on what the expressions are and where they show up, you might get systems of equations. So if this was like a 2y here, instead of x, you would then need to look somewhere else in the problem and probably at that other transversal to get another equation that has x and y in it. Does that make sense? Okay. So those are little things that might help you through the rest of that assignment.